Welcome to this video lecture on pricing decisions. Prices for products have historically been set based on the cost of the product. So first, firms would come up with the cost of making the product or the cost of providing the service, and then from that cost they would add a markup or a margin to determine the selling price. So in short, the cost of the product had a much larger influence on the setting of the selling price. However, over time, many other factors have come into play which now influence the setting of the selling price. Some of these factors include the demand. The higher the demand for a product is, the higher the selling price will be. The lower the demand, the lower the selling price will be. Other factors also now include quality of a product. You find that if a product is of high quality, to fetch more. If a product is of low quality, to fetch less. Competitors have also come in play, where there are more competitors providing one service, a similar service, or selling a same product. They will first want to know how the other competitors will react before they increase their selling price. Failure to take into account the actions of competitors would render one to outprice themselves out of the market. Another factor which has come into play to influence the selling price is substitutes. If a product has a substitute, then the sellers of the product will have to take into account how the substitute product will affect the increase in the price, because you may just increase the price of the product and customers may not be happy with that increase, so they'll switch to the other substitute. Inflation has also become a factor. The higher the inflation, the higher the prices of products be. When inflation reduces, prices tend to also reduce. The age of a product is also another determinant. As products become old, they tend to fetch less because most people who have acquired that product, and most likely some of these products, they will be superseded by more superior products. And lastly, disposable income. When the disposable income of individuals increases, then they'll be able to afford to buy more products. That will also result in prices of products increasing. If disposable income reduces, that will result in some products, not all, but some products selling at lower prices. We now look at the theory on demand. The economic theory on demand is that the higher the price charged for a product, the less demand there will be for normal goods. To measure this change in price due to changes in the change in demand due to changes in price, we use the price elasticity of demand, which is a measure of the responsiveness of demand to changes in price. Some products are more responsive than other products. In the formula that we use to calculate the price elasticity of demand is given as follows. It's the percentage change in quantity divided by percentage change in quantity. When the PED that you calculate is greater than 1, it means that the product has has elastic demand, which means that a small change in price will cause a proportionate greater change in quantity, and where the PED is less than less than 1, this implies that the product has inelastic demand and prices can be changed greatly without creating large changes in demand. So firms need to be aware of the PED of their products, as this will assist companies when setting prices, because when demand is inelastic, prices can easily be raised, and if demand is elastic, a decrease in price will result in an increase in sales volume. So an increase in price where demand is elastic would result in the opposite, to result in a decrease in the volumes demanded by customers. Let's now look at an example. A football club charges $12 a ticket for home games. Average attendance at these regular games is 16,000, and prices were increased by $1 per ticket. Attendance fell by 2,500. Determine the PED if ticket price increased from $12 to $13. So there's an increase of $1 there. So the percentage change in price will be calculated by the increase, which is $1, divided by 12. So that gives us an increase of 8.3%. Then the percentage change in the number of tickets will be calculated by the 2,500 fall in the ticket sales divided by 16,000 to give us a 15.6% decrease in the percentage change in quantity. So our PED is negative 15.6% divided by 8.3%, which gives us 1.9. This means that the demand is elastic. Since we're said when the demand is greater than 1, when the PD is greater than 1, then demand is elastic. We move on to look at the demand function. Price will affect the quantity demanded for a product. Output consideration will alter the price to be charged. If the demand function is known and the desired output has been calculated, then the appropriate price can be determined for the product. So to do this, we use the demand function. This demand function is usually a downward sloping curve. Since demand falls when prices rise and demand increases when prices decrease. So if you have a downward sloping demand curve and it becomes steeper, it means that demand is becoming more inelastic. If the demand curve becomes shallower, it means that the demand is elastic. We use the demand function formula, which you have to memorize. In some exams, the formula is given, but even if it's given, you still need to know how to use it. The demand function formula is given by P equals A minus Bx, where P is the selling price, Q is the quantity demanded at that price, A is a theoretical maximum price. If price is set at A or above, then demand will be 0. Then the B is given by a formula, change in price divided by change in quantity, which is also the gradient of the line. This represents the change in price required to change demand by 1 unit. We apply that in the second example. Lecture example 2. A football club charges $12 per ticket for home games. Average attendance at these regular games is 16,000. When prices were increased by $1 per ticket, attendance fell by 2,500. Assume attendance to be purely price dependent. What should be the ticket price to ensure a full house with capacity being 25,000? We put up our demand function formula and substitute in the formula. First we find B. We know price increases by $1. So, and attendance fell by 2,500. So 1 divided by 2,500 gives us B as 0.0004. We know what our P is 12. So we substitute in the demand function formula. 12 equals A minus 0.004 times 16, which is our Q, which gives us our A as 18.4. We can now substitute the 18.4 in the demand function formula to compute what we are being asked. So we want a price which will enable us to fill this 25,000 seating capacity of the stadium. So we substitute Q with 25. So the selling price that will fill the stadium to capacity will be, if we sold the tickets at $8.40 per ticket. We proceed with the optimal pricing. This is a desired level of output which can be determined graphically by plotting total cost and total revenue lines. It is another kind of break-even chart which is used by economists. So in this chart you've got your marginal revenue line there and marginal cost line there. Then you've got your total cost line there and your total revenue line there. Where these intersect, that is your optimal output point. This they'll rarely ask you in the exams, but just for knowledge purposes. But you need to apply this knowledge in the marginal revenue function formula. So the gradient of the total revenue line is known also as the marginal revenue. This is the increase in total revenue from selling one more unit, and is given by the formula MR equals 2 minus, beg my pardon, MR equals A minus 2BQ. The gradient of the total cost line is known as the marginal cost, which is also the increase in total cost from producing one more unit. So the profit is maximized where these two gradients are equal. That is where the marginal revenue equals the marginal cost. We'll continue with the computing the optimal pricing approach in the second video.